So good morning once again. As Azade has introduced me, I'm Pamela Ochungo, and I work with the British Institute in Eastern Africa as part of the MAEASaM project, that is the mapping of endangered archaeological sites, Africa's endangered archaeological sites and monuments, that is also funded by Arcadia. So today we'll be looking at the MAEASaM approach of working with historical maps in practice. So this is what my presentation will cover today, and we'll start with why historical maps matter for heritage research in Africa. Then we move through the two technical processes at the heart of this work, that is digitization, that is getting from the physical archive to a digital resource. And then secondly is georeferencing, that is placing the digital map into the real world coordinate system. And this will be done, shown using QGIS. And we'll also look honestly at the challenges in terms of what tends to go wrong and what you can also expect to go wrong and how we fix it. And then we'll close with NMK and BIA. NMK is National Museums of Kenya, and BIA is British Institute in Eastern Africa. So we'll close with our experience, what this work has actually produced. So each of these steps builds on the last so that by the end, we should have a complete picture of the pipeline and not just isolated techniques. So Azade has already talked about what is on a historical map, so I won't dwell too much on that. But before we get to those maps of ours, it is worth pausing on what a historical map actually contains, essentially what you should examine or look out for before you start digitizing or georeferencing anything. So this example, this is an El Fasher sheet, the Anglo-Egyptian Sudan, which is based on a 1:250,000 scale from 1937. It's not one of our maps, but it shows features you'll find on almost any colonial era topographic sheet. So on the top margin, where you have the red rectangles, carries the scale and the sheet number, and I've just blown it up a little bit over there so that you see what that looks like. And this is essential for sourcing companion sheets because you need to know what comes before, what comes after, what is adjacent to this sheet, so that then you can form a complete picture of that particular area. And you know, there are some features that actually are across the map sheets, right? Some of these features go across the map sheet. So this is very useful for when you want to stitch together these maps to be able to identify features that go across the map sheets. And then we have the legend. So there again, I've highlighted at the bottom the legend and blown it a little bit part of it within the map. So the legend tells you what the surveyors chose to record. Here in this particular map sheet, you have antiquities, you have localities, you have tribal names, you have deserted features of villages and so on. And then you also have at the bottom part of the margin, you have the publication date and the compilation sources, which tells you how current the information was when the map was made. And then you have the coordinate grid, in this case in degrees minutes, and this is what we will use later as ground control points for georeferencing. So reading these margins is really important, and reading them properly makes the difference between a clean georeference and what could be a frustrating experience. Now, what is the importance of historical maps in terms of complementarity of information? So I want to make one point clearly here. A historical map rarely tells the whole story by itself. It becomes much more powerful when you read it alongside other digital or other archival material. And here you see a compilation of other archival material from the National Museums of Kenya, graciously provided by Angela Kabiru, who is my colleague at the BIEA. So you have, for instance, those field notes, you have accession files, you have all sorts of information that were being recorded by researchers when they went to the field. So this is what you're looking at this screen. So these are the NMK site records, a topo map, a 1935 government notice. So that's the government notice from 1935, which gazetted protected antiquities and monuments under the preservation of objects of archaeological and paleontological interest ordinance. And if you look at this particular record here, the Gazette notice, it's very interesting because it really does not tell you what is where. So it just mentions, for instance, ruins at Diani, ruins at Tiwi, wall tower at Tumbe, etc., etc. And then at the bottom is the more interesting part, because now at the bottom you have the Nyanza province. And it talks of a place called Kanam Kanjera, fossil beds. And this is how they describe it. So they talk of commencing at a point situated on the straight line adjoining Homa trigonometrical station and Homa Point, and distant 2 miles from Homa Point. And then it continues with, information such as moving southwesterly on a bearing of 247 degrees, 80 minutes approximately for a distance of about 2.25 miles, thence northwesterly on a bearing of 294 degrees, 30 minutes, etc., etc. So you can imagine just how difficult it can be to locate this kind of sites without having actual coordinates. But this is the reality in terms of what we have in our archives, and therefore why historical maps and georeferencing them becomes really important. So the combination gives a much fuller, more verifiable picture than the map alone ever could. So what is the first practical step then? This is digitization. And which maps did we decide to digitize? So we had mainly two kinds of maps. And first, we're talking about maps that are showing heritage sites that are already published. So some of the maps come with sites that are already published within them, and they appear in the formal record. Secondly, we have maps, and this is the majority of the case. We have maps where field researchers went with these maps to the field and physically annotated these sites by hand. And here we have an example of two different types of maps. So you have one, the Kilgoris sheet. It is a good example whereby you can see a researcher circled an area of interest and noted features in the margin, like forts and ancient ruins. And then you also have the other sheet there whereby you have a less accurate map, but also with features like forts that are recorded on them. And we have a lot more. For instance, this is another map sheet that we have scanned and georeferenced, whereby you find alongside the coast, you have hand annotated sites. As well, on this sheet, you have, hand annotated sites, and on this one as well. So you can see here, you have on the left part, on the western part of the sheet, you have this site here labeled Molwaraba, in pen, and so on. And so therefore, when we digitize and scan, when we digitize and georeference these sheets, then we're able to pinpoint the coordinates of these sites and record them as sites that were existing, and probably some are still existing or may have disappeared. Now, we try to scan these sheets at a relatively high resolution, that is 400 to 600 dots per inch. And this matters because then it ensures that we preserve the fine detail that is found in these maps. For instance, the handwriting that can be quite faint, the marks, the faint grid lines that we depend on later when we georeference. So if we do not use a pretty good resolution, then it might become a problem for georeferencing at a later date. Now, these are just examples of some of the topographic map sheets that we have at different map scales, and these are also annotated sheets. So this is one called Balesa Kula, which is somewhere in the northern Kenya. At 1:100,000. You also have another one at 1:50,000 called Entasekera. And then in Kisumu, that is towards the western part of Kenya, you have a 1:250,000 War Office and Air Ministry map from 1962. So all these are annotated. All of them carry field annotations, but from different surveys, different decades, different surveying agencies. And that's actually a useful illustration of the underlying challenge, meaning there's no single standard scale or format across this archive. So our digitization and georeferencing workflow has to be flexible enough to handle that variation rather than assuming that everything is going to look the same. Now, what about georeferencing? So this is a very short video, graciously done by our two BIA MAEASaM interns, that is Cindy and Keith, and this shows the process of georeferencing. So I'm playing it. I hope it's showing on your side. So it's showing here the overlay of historical maps, then adding of control points, which you're going to do later on, which are known as ground control points. Then in our case, we enter the UTM coordinates, and then we carry out the transformation using, for instance, polynomial 1 or 2, and then the map is now georeferenced and is placed in the right place. So this is essentially the process that we're going to go through. Now, in our particular case, we have to carry out a process called reprojection for our particular maps. And most of these colonial era maps were surveyed using a datum that is the ARC 1960 datum, which is a transverse Mercator projection at the Clark 1880 modified spheroid with the UTM zone 37 parameters. And you can see these original parameters in the scanned map margin on the right. So what I've shown there on the right side is what you'd find on the margin to give you this information. So to make the data usable in modern GIS and comparable with GPS coordinates and also our base maps like the Google satellite base maps, we have to reproject it from the ARC 1960 datum to the WGS 84 datum. So essentially, we have to do that. So then, this is the really payoff slide. So what you're looking at now, following that process that I showed in the video, is a fully processed map. It has been scanned, it has been georeferenced, and it has been reprojected, and then overlaid on a current satellite imagery of the Kenyan coast. So the sheet here is in the Kenyan coast, and if you look at the inset, you'll see some handwritten annotation from the original survey reading, ruins, mosque wells projected near a place called Munge and Nzovuni. So I've just blown it out there so that you can see there's some writing there, meaning the researcher had annotated it when he went to the field. So that's the whole point of this workflow. A note that somebody wrote on a paper map decades ago can now be pinpointed precisely enough to guide a present day ground survey. Now, what are the challenges? The challenges are many, and I will just talk briefly about them. So you have inverted or mirrored maps caused by incorrect coordinate metadata or orientation errors. And we fixed this by using 4 reliable ground control points using degree minute coordinates plus polynomial 1 transformation. You also have corrupt, unreadable files, which sometimes appear as black images, which we fixed by rescanning. Of course, the usual map age and paper distortion, whereby when it's shrunk, it shows wear and tear. Also, systematic inaccuracies from historical surveying techniques, usually fixed by additional ground control points and careful visual verification. We also have incorrect spatial placement, whereby some maps appeared in Greece or in the US. You have poor scan quality and damage, and some sheets were also lacking adequate reference information. And these are just examples. In the first map, you have an upside down map, it's inverted. Therefore, what do you do with this? In the second map, you have no information on the reference, the sides. So then how do you reference this? So these are some of the challenges we faced and that you may also face when you start this process. And so I want to end this by thanking all the institutions that are involved, the Acadia Fund, the project, our project MAEASaM, and the BIEA National Museums of Kenya, University of Cambridge. Thank you very much.